people of YouTube. We're back. Last lesson for the probability and counting unit. And it's going to be kind of a split lesson, lesson 4 or 5, because just kind of stuck 2 chapters together. And it is the Binomial Theorem and Pascal's Triangle. So, Pascal's Triangle is, guess what, shaped like a triangle. Kind of like a pyramid. It's a pyramid scheme is made by this guy named Pascal. Absolute genius. Very talented thinker, mathematician. You should Google him. He's actually very interesting. So right here, this is Pascal's triangle. It's just a pattern of numbers that I don't know how the heck he came up with it, but it turns out that this can help us expand higher order binomials and polynomials. Okay, so if you have like x plus y, in brackets raised to the power of 8, this pattern of numbers actually is the coefficients of each term. So the very, very top row, we call it row 1. Row 2 is, and you're going to see this sort of weird pattern emerging. So row 1 starts on 1, then it goes 1, 1. And then row 3, which has 3 terms, goes 1, 2, 1. And then row 4 is 1, 3, 3, 1. And if you're wondering what the pattern is, well, if you check it out here, in order to get this 2, and whoops, here we go. Oh, perfect. I didn't, Oh my goodness. In order to get this 2, what we're doing is you're actually adding up these 2 numbers here. So if you go 1 plus 1, you get 2. In order to get this 3, you go 1 plus 2, you get 3. Okay? And then you go 2 plus 1 to get 3. So always on the outside, you have 1s. You're noticing, just looking down, there's always a 1 on the outside. Okay, so if you're in row 5, you're looking back at row 4, and in order to get this number, you go this term plus this term. That gives you the 4. Okay, and then this term plus this term gives you the 6, and then 3 plus 1 gives you 4. Okay, so if we were figuring out this one, again, we have 1s on either side, and then you go this term plus this term would give you this term here, so that's 5. And then 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. Okay, so lots of patterns emerging. You're noticing that there's always 1s on the end. And the further out you expand, you're going to see the same number coming up. So 4, 4, 5, 5, 6, 6, right? And to get these middle terms here, so 1 plus 5 gives us the 6. 5 plus 10 gives us this term, 15. 10 plus 10, 20. 10 plus 5, 15. So you see all this repetition. Before we go do row 8, let's count how many terms there are in each row. So 1, 2, 3, 4, 5, 6, 7. So row 7 has 7 terms. Row 6 has 6 terms. Okay, so to do row 8, we know we can expect 8 terms. And you're going to have a 1 on each side. And then to get all the middle terms, just start with row 7 and go 1 plus 6, 7. And then the next term is 6 plus 15, 21. And then 15 plus 20, 35. And then 20 plus 15, 35. And then 15 plus 6, 21. 6 plus 1, 7. So you see that pattern emerging where you have the 2 7s, the 2 21s, the 2 25s. So that goes on and on and on. Now, on the exam, this is not on your formula sheet. You just need to sort of memorize how to construct Pascal's triangle. And they generally don't go further than row 5, 6, or 7. Okay? So you should know how to construct it. And we'll get there. You just have to practice. That's basically where it comes from. So what can we use it for? Well, let's look a little bit more at where all these terms are sort of coming from. Okay, so if we evaluate these combinations, and I would just say, let's just quickly type them in on our calculator. This one here is going to give you 1. This one here is going to give you 4. This one here is going to give you 6. This one here is going to give you 4. This one here is going to give you 1. Well, compare those numbers, 1, 4, 6, 4, 1. Compare that to Pascal's triangle. And what do you notice? Let's go take a look. This is row 5. Row 5 of Pascal's triangle. There's 5 terms. Whoops. And it turns out that if you do the combinations, starting with the n value of 4, starting on 0 and going up till you get to the same r value as your n value, it actually gives you a row of Pascal's triangle. Okay? So how could we sort of summarize that? Well, this is row 5. So this is row 5. Therefore, say if we want to find row 6, then we're going to use an n value of 5. So if you're using combinations to figure out Pascal's triangle, and you want to know row 6, you actually start your n value off at 5, and this makes sense because, and then you're going to go 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. How many terms are there? 1, 2, 3, 4, 5, 6. Okay? Wunderbar. Perfect. So, remember, the row number tells you how many terms. Okay? And if you were to use n equals 6, you would actually get an extra term. Okay, so you just got to remember that if you're using combinations, the n value is 1 less than the row value. So n value is the row number, let's say, minus 1. Okay, so row number minus 1 will give you the n value. That's another way you can calculate Pascal's triangle. So we can actually rewrite Pascal's triangle. Sometimes it's written using just combinations. We just explained like why, so that we answered that question. But if we were to go fill this out, okay, so remember on Pascal's triangle, this would be like 1. This is 1, 1, 1. And then remember the next row is 1. 1 plus 1 is 2, 1. Here, so we can fill it out, do some practice so we can put 1s all the way down. Then we'll do it with combinations. To get this one, we go 1 plus 2, 3, 2 plus 1, 3. To get this one, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. So with combinations, this is row 3. So the n value starts 1 less. So it's 2C0, 2C1, 2C2. I'm talking like a robot now. Might as well just roll with it. This is row 4. N value starts 1 less. So 3, choose 0. 3, choose 1. 3, choose 2. 3, choose 3. I'm really digging that voice. You get it, okay? As an exercise, you should try filling out the last row. This is row 5. Pause the video. Try it out. I'm going to write it. So 4C0, 4C1, dot, 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 until you get to 4C4. Okay? All right. So I kind of summarized that below. The fifth row starts with 4C0. It ends with 4C4. Let's not do this. Actually, sure, let's do it. Using this concept, write the numbers for the 7th row of Pascal's triangle without writing the first 6 rows. Okay? So if you were writing row 7, so don't go back and look. If you were start doing row 7, the n value starts at 1 less. You start with n equals 6. So if you got a calculator handy, the easiest way to write that row would be to go like this. Would be to type in each one of these on your calculator. Now, if you really know the pattern, it doesn't take long to sketch out the triangle. Certainly something, you get scrap paper on the exam, something that you may do. They always ask a question that has to do with Pascal's triangle. So let's keep going so we can kind of get to some of those questions. So I promised you that we'd be able to expand binomials using Pascal's triangle. Okay, so in this example, I ask you to expand 2x plus y to the power of 6. That's a lot of foiling. Now, you really don't want to do any of that work, believe me. So let's take a look at just x plus y and see if we can figure out how we can use Pascal's triangle to do this, because it's not obvious. Okay, so anything to the power of 0 is 1. Right? So we know that. So I'm going to write this in sort of a strange way, but it's going to help us see the pattern. I'm just going to write it as x to the power of 0 times y to the power of 0. And that equals 1. So that's that one expanded. This one here, so I'm basically using Pascal's triangle. Okay, so notice the coefficient here. Notice how the first row has just a 1. check this out now. When I expand this one, it's just x plus y, right? But if I want to use Pascal's triangle, the coefficients are 1 and 1. And it just happens to work out that if you go 1 times x to the 1, y to the 0, plus 1, x to the 0, y to the 1, okay, and then y to the 0 is 1. So you just get x plus y, right? X to the 0 is 1. 1 times 1 is 1. You still get the right expansion, but something's going on here, right? So here's the coefficients of row 2 of Pascal's triangle, and something's happening with the powers as well. It becomes a little bit more obvious when we get to this one here. So now my power is 2, and if I go write row 3 of Pascal's triangle, so this is row 3, check out these coefficients. When you expand this one out, what do you get? Well, you get 1 x squared y to the 0 plus 2 x to the 1 y to the 1 plus 1 x to the 0 y squared. Now, this isn't obvious, but if you clean it up, what do you get? You just get x squared plus 2xy plus y squared, right? I just evaluated all the powers of 0. This is the regular expansion that you would get to. Nobody would ever write it like this, but what are we noticing here? Coefficients of row 3 of Pascal's triangle. What else? Look at just the x term for a moment. Check it out. X squared. In the next term, the power goes down by 1, so now it's x to the 1. In this term, now it's x to the 0. Look at just the y term. It starts on y to the 0, and its exponent goes up by 1 every time. So I wonder if that weird way of expanding this works for something like this. This is a lot more work to expand, right? You'd have to take this answer and then multiply it by x plus y again. Okay, but if I use row 4 of Pascal's triangle, so what would row 4 be? Well, I know it's 1, 1, and then I go 1 plus 2, 3, 2 plus 1, 3. These will be the coefficients of each term. And if you don't believe me, you can plug this into Wolfram Alpha or something or expand it out by hand, but I guarantee you that my answer is right here. So check it out. So we go first, we do the first one, and then this thing to the power of whatever is here, 3. And then whatever is here starts at the power of 0. Then my next term will be coefficient 3. X to the power of 3 goes to x squared, and this one always goes up by 1. Next term, again, it's a 3. The x term goes down by 1. The y term goes up by 1. And then last term, coefficient of 1. X term is now at 0. Y term is now at 3. So you'll never have a power higher than this. Okay? When you clean this up, so to speak, like get rid of all the y's to the 0, what do you get? You get x to the power of 3 plus 3x squared y plus 3xy squared. X to the 0 is 1 times 1 is 1, so we don't generally write that, so you just write y to the power of 3. Pascal realized that there was a pattern here, and he basically constructed this neat little triangle that predicted all the terms beautifully, and then it ended up getting used in probability, a lot of connections to probability. I don't think any of these things are coincidences. So if we use Pascal's triangle to do this one, okay, this is going to be row 5. Now, we can use combinations, right? So for combinations, we know that n would start at 4. So we could start expanding it as saying, well, okay, I didn't write out row 5, but we know we can go 4c0, and then it's whatever this is to that power, so to the power of 4. And then whatever this is to that power, whatever this term is to the power of 0. And then we go 4c1. Remember, x term, power goes down by 1. Y term, power goes up by 1. And you just keep that pattern up until you're done. Okay, so x squared coming down from x to the 3, y to the 1 from coming up, right? Going up by 1. Keep going. You'll know you're done when you get to 4c4. Okay, so this should be x to the 1. This would be y to the power of 3 plus 4c4. So in the last term, the x coefficient should be 0, and it is, and this coefficient should have gotten to whatever power or exponent you have there. Then you can go type this in or go figure it out, whatever you want using Pascal's triangle. Okay, I'm going to leave it there. On the exam, sometimes they ask you to expand something like that. You never know what question you get on Pascal's triangle, but sometimes it is one of these expansions. I think we pointed out what pattern do we notice with the numerical coefficients, right? It's Pascal's triangle. Okay, and whatever this power is the n value for the combination. It's the n value for the combination. All right, so, this was 4C0, 4C1, okay? Here we used row 4, right? When the n value would have been 3. So 2 ways to think of it. It's the n value for the combination, or it's 1 less than the row number, okay? So that is confusing, because if you think of it with the row number, then you look at this power and it's the next row in Pascal's triangle. If you're doing it with combinations, then this is the n value, okay? You got to keep it straight in your head, man. You just got to memorize it. Don't know what to tell you, okay? Wunderbar. This is a bit of a longer lesson, by the way. So, could we use this pattern to expand this one out? It's a bit of a nightmare. They wouldn't give you one quite this long on the exam, I can guarantee you that. But it's a great exercise to do. So let's try it out. You might want to just pause, see if you can get it on your own, and then see if your number matches mine. I will give you a hint. So if the power is 5, this is row 6, or we can use n equal 5 if we're going to use combinations. You pick. I'm going to go ahead and use combinations. So I'll go 5C0, and then it's this thing raised to the power of 5. So it's a to the 5. And then it's this term raised to the power of 0, and then I just go. Follow my pattern. 5 choose 1, a to the 4, b to the 1, plus 5 choose 2, a to the 3, b squared, plus 5 choose 3. A value comes down by 1, the b value goes up by 1. Yeah. Rubs the lotion in. So 4C4, a to the 1, b to the 4. Last one, 5C5. A to the power of 0, b to the 5. Man, never have expansions been so easy. We should have just showed this to you in grade 9. Just kidding. Okay, some knowledge of Pascal's triangle is going to help you here, right? Because you know this is 1, right? Because the first term and the last term are always 1, okay? This is 5. This is 10. This is 5. And no, I made a mistake somewhere. I missed a 10. It's 5. This one here is 10. This one here is 5. There we go. Perfect. Remember, you can also use that rule that we learned, like when the R values of the combination add up to the N value, those two combinations have the same value. So if this is 10, then this is 10. And if 5C1 is 5, because this is 5C4, 4 plus 1 is 5, they have the same value. So it doesn't take long to really figure this out if you know your stuff, you know. Okay, then you got to clean it up. So if this was on the exam, you'd have to clean it up. So this is just a to the power of 5. Right, b to the 0 is just 1. This one is going to be plus 5a4 times b plus 10a3b squared plus 10a squared b3 plus 5a b to the 4. And then the last one, a to the 0 is 1. 1 times 1 is 1. So we just write b to the power of 5. Yay! Great. So, how many terms does this expansion have? 1, 2, 3, 4, 5, 6. It has 6 terms. Well, we've been talking about that, right? It has 6 terms because it's row 6. I will point out that it always has one more term than the exponent here. Okay, but sometimes they just ask you little theory questions like that. So, we did that. So, it's one more term than the exponent or power. Okay, so if they just said how many terms would this have if you expanded it, well, you're not going to expand it. You're just going to say, well, the power is 10, so it's going to have 11 terms. Yeah, you guys are so smart. Smiley face. Okay. Wow. Well, this whole Pascal's triangle thing gets wrapped up in something called the binomial theorem. Now, what the binomial theorem is sort of the official word on the street of how we expand a binomial, hence the word binomial theorem. So if you have a binomial that looks like x plus y to the power of n, you use Pascal's triangle to expand it, and the n value tells you what this number is, and you go nc0, nc1, nc2 until you get to ncn, and then it also shows you what happens to the powers, right? So it's take this first one, raise it to the power of n, and then it's n minus 1, n minus 2. In the meantime, take this one, and it's raised to the power of 1, then the power of 2. Okay, I do believe that this might be on the formula sheet. It might be. I can't remember. Okay, so I should have looked it up before. I believe it is. I believe it is. Let us expand this one here. Now this one's a little bit different because it's all of a sudden this is a monomial that has a coefficient. Okay, so it is the first term raised to the power of n. So I'm gonna get yeah, let's do this one. This is gonna be everything we need. Again, definitely longer than what you could expect on the exam if it comes up. Okay, so remember, the power gives us the n value for the combinations. Otherwise, we'd be using row 6. It's always one more, right? And there's 6 terms. So a couple of things to remember. Expanding it out. So it's going to be 5c0. Now, in the case of a monomial like this, where you have a coefficient, you make sure you use brackets. So it's this thing raised to the power of 5, right? And then it's here, you take the negative 3. So you take the sign with you, and that's raised to the power of 0. So this one's got a lot of things going on, right? Because you got to worry about the sign, and you got to worry about putting brackets, and then, doing the work. So we go 5c1. That's going to be 2a to the power of 4, and then negative 3 to the power of 1, plus 5c2. Again, it's 2a to the power of 3, negative 3 to the power of 2, plus 5c3. Oh, 2a squared, negative 3 to the 3. Oh boy, we are getting closer. 5c4, 2a raised to the power of 1, negative 3 raised to the power of 4. I'm going to kind of run out of room, so I'm just going to squeeze it in down here. 5c5, 2a to the power of 0, negative 3 to the power of 5. And then happy expanding. So, Pascal's triangle, right? This is 1. This is 1. This is row 6. So, no, if you can think of the row before, whatever. Oh, gosh. We can go back. Is it 3? I can't remember. Let's just go back. Row 6, right? Row 6. Row 6. 5, 10, 10, 5. I think is the one we just did. I knew it looked familiar. I don't have a calculator with me, so here we go. So it's 5, 10, 10, 5. Okay, what else makes this hard? Well, you actually have to go to the power of 5. So you get 32 times 1 and a to the 5. So you get 32a to the 5. Anything to the power of 0 is 1. Okay, so the negative goes away. This term overall will be negative. You got negative 3 to the 1. So you got 5 times 2 to the 4, which is 16, times negative 3, which gives you negative 240, and then a to the 4. Okay, this 3 didn't have a variable, so we don't have a second variable here. Then we go 10 times 2 to the 3, which is 8, so 80 times 9. That gives you 720. And you get a to the 3. Okay, next term is negative. It's alternating negative. If you think back to series and sequences back in grade 11. So you got 10 to the times 2 to the 2, which is 4. So 40 times negative 27. You get negative 1080. And then you get a squared. Okay, and then 5 times 2 is 10 times negative 3 to the power of 4. Gives me, I believe, 810. Obviously, you'd have a calculator, okay, so don't freak out. But you need knowledge of Pascal's triangle in order to do this question. And again, this is a little bit longer than what you get on the exam. Okay, perfect. There it is. Wow. there is a way to find just one term instead of the entire expansion. So sometimes they sort of ask a question in the exam like, what is the middle term or something like that. We'll do some questions like that in later on in the lesson. But let's look at term 4. So where is it? 1, 2, 3, 4. Here's term 4. What if they just said find term 4 of this expansion? How could we do it? Well, what was the R value if we go back in our work? So what was the R value of the combination? So 1, 2, 3, 4. Aha. So here's term 4. Let's take a really close look at term 4. So if they're asking term 4, we already know the n value comes from here. So we know we go n, c, and then this is going to be like your term minus 1, right? Because the value was 3. And then what do? We do the first thing. So we do x to the power of, well, it was 5 minus 3, right? So it's whatever n subtract t minus 1 is, times the y term, which again is just this, raised to the power of t minus 1. So we sort of kind of came up with a formula on how to find a specific term. This is on your formula sheet. I believe they use different letters. Okay. However, this formula is on your formula sheet. So if we wanted to find a specific term, we could use this formula. Again, I'm pointing out how the R value in NCR is 1 less than the exponent of the binomial. Okay. So great. Perfect. So if they're asking for term 4, remember, you go the term minus 1, and that gives you that number. And then you just look, n is whatever number this is, x is whatever is here, and y is whatever is here, and everything else you know. Perfect. Delightful. I know, we saved the best topic for last in this course. Okay, so I mean, we can do a bazillion examples, and we should, because this stuff ain't easy. This one says expand and simplify this, and then down here it says let's just look at the third term. We've expanded so many of these now that I feel like I'm tired of expanding them. So why don't we just use our general term formula, okay, instead of expanding the whole thing to find the third term. That's what I'm going to do, okay? So here it is, that same formula that I wrote out a moment ago using the k instead of t. If you go into math, you're going to get used to formulas and the variables in them like changing constantly. So just get used to it. I think your formula sheet uses a different letter here, okay? But it's the same formula. Okay, should be able to apply it. So if I want to find term 3, let's see. I want to find term 3. So k is whatever term I'm looking for. N is whatever the power is here, right? X and y are these terms. So this is x is 2, c to the 4, and y is negative 1. So if I use my formula, then I go 3, because that's the n value, c, and now it's k minus 1, so it's going to be 3c2. And then it's whatever x is, so 2c to the 4, raised to what power? It's n minus k minus 1, which is this number here. So it's going to be raised to the power of 1. And then the y term, so negative 1, raised to the power of k minus 1. So k minus 1 is 2. Perfect. Now, this is generally a question that does come up on the exam. They're more likely to ask you for one term in an expansion than an entire expansion, because this is way less work. And it still requires a lot of knowledge of the binomial theorem. Okay, so then you'd pop this in on a calculator or calculate it by hand, whatever it is. I don't know if I actually ever ended up calculating it here. No, I did. So 2 to the 1 is 2. So you just get c to the power of 4. Negative 1 raised to the power of 2 is just positive 1. This thing here, 3c2, evaluates out to 3. So you got 3. That's 3. 3 times 2, 6. There, done. Woo! I know that seemed complicated. I recommend you play it back, pause it, try it again, try it on your own, see if you can do it. Okay. Don't worry, though, because we're going to do another one right away. Let's find the 7th term in this expansion. So, n is 9. K is whatever term you're looking for, so 7. My x value is x, so that's great. My y value is -3. So, to find term 7, I'm going to go 9, it's n, c, k minus 1, 6. Take the first term, x, raise it to the power of n minus k minus 1. So in this case, I should say 3. Take the next term, the y term, and it's raised to the power of k minus 1, so 6. Pro tip, this plus this should always equal that, or you're doing something wrong. Okay, expand it all out. Let's see, I think I get 84. X to the 3, so 9c6 is 84, x to the 3. And then when you go -3 to the power of 6, you get 729. So multiply it all together, you get 61,236 x to the power of 3. Hurrah! That's hard, man. I know it's hard. I know it's rough. But there it is. Whew! We're making it. We're going. So we can do another one of these. Let's see. I got determine the 5th term of this. If you want to try it yourself, honestly, this is harder than they go on the exam with the fractions. So let's just skip. We get it. And if you want to try it, you can certainly plug it into Wolfram Alpha and get the expansion and go find the 5th term. Okay, there's no lack of availability of answers on the internet. But we should do this one because the wording, and they do like doing this on the exam sometimes. I've seen this question on the exam before. Determine the middle term of this one. Ooh. What would the middle term be? Well, how many, so this is the n value, right? The n value is 10. Remember, this would be row 11, right? It's always one more than the power. So what would be the middle term? If you have 11 objects, well, it would be term 6. I don't know if it's worth the time, but just in case. So I'm just writing out all my terms here. Which one's the middle term? 6, right? Got 5 terms over here, 5 terms over there. Wunderbar. So make sure you know how to do that. All right, how do I know it's term 6? The formula really, if you're looking for a formula, it's take the power, divide by 2, and add 1. When you have an odd number of terms, that's always how you find the middle term. Okay. Here we go. So we have everything we need. We know the k value is going to be 6 because we're looking for term 6, and we have all the info. So I'm just going to jump straight to going 10, c, and then remember it's k minus 1. K is 6, so we go 5, and then it's 2x. Raise the 10 minus 5, so 5. And then it's the next term, so with the negative and everything, what a nightmare. And this plus this has to equal 10, so that's a shortcut you can use. There we go. So that would be worth a mark or so, maybe a mark and a half sometimes. Sometimes the breakdown's weird, but it's generally half a mark for each piece, and one piece is sometimes worth more. Anyways, this is 252. 2 to the power of 5 is 32. And you get x to the 5. And yeah, this is ugly here. So you get 2 to the 5 in the bottom, which is 32, and then x to the 5. So this is interesting. When you multiply it all out, 32 divided by 32 is 1. X to the 5 divided by x to the 5 is 1. So you just have -1 times this. So you get -252. Ain't that odd? But that's what you get. So there you have it. All right. We're into the home stretch here. I'm definitely getting a little tired. I know the video's long. The last topic that sometimes happens is they will ask you to identify a term that has a specific variable in it. This is not easy, okay? Doesn't pop up in every exam either. So definitely worth knowing though. So in this expansion, find the term that has x to the power of 14. Huh? How do we do that? That's hard. Well, there's a pattern to all this stuff, right? So what I recommend you do is you go find yourself term 1. Okay? So use the knowledge of the general term formula, right? So n is 11. You know, this is your x variable, this is your y variable, and you're finding term 1. So k is 1, so you get k minus 1, 0. So 11c, 0. You should know how to do this. This is 2 to the x, and it's raised to the power of n minus this, so 11. And then the next term, which is the x squared term, remember, this plus this has to equal n, so this is 0. Shortcut. Okay, evaluate this. Okay, now, because we're just looking for a pattern for the x term, we don't really care about the 11c0. It doesn't help us, right? We're just, what happens to the variable? So I don't even need to worry about going 2 to the 11. I don't care. That doesn't affect the variable. What's affecting the variable? This and this. So you're going to get x to the 11 times, and the negative sign doesn't matter, 2 to the power of 0 is still just 1, right? Anything in power of 0 is 1. So you get, well, I guess you get x to the 0, right? My bad. Like, perfect. Right, so at the end of the day, you get this. Yeah? Right? Like, this is going to go away. Anything to the power of 0 is 1. So I guess another way of thinking of it, this is 1. So this is 1. You get x to the 11. Perfect. You need to find the next term in order to establish the pattern. Okay, so again, we don't care about this. If you want to write it out, fine. But you don't need to calculate it. What happens? It's this term, right? What's the pattern when we were expanding them out? This power comes down by 1. This power goes up by 1. What's happening to just the x's? You get x to the 10 times x squared. Okay, so back to grade 9, multiplying, add the exponents, you get x to the 12. Well, guess what? This is the pattern. It goes up by 1 every time. So term 3 would have a coefficient of x to the 13. Term 4 will have the coefficient x to the 14. That's what they want. So find the term containing x to the 14. I've established it's term 4. Now I can use my formula to actually go calculate it, right? So k value is 4, right? So it's n. N is 11. So 11c, k minus 1, 3, 2x. And it's 11 minus 3 is the power. So it's 8. And then negative x squared. This plus this power has to equal 11, so this has to be 3. That's how I like to do it. Go calculate it out. You'd have your calculator. I believe you get 165 for the combination. 2 to the 8 is 256. And then times x to the 8, so x to the 8. The negative sign is going to stay, so I'm just going to throw a negative out here. I got a negative raised to an odd power. And then 2 times 3 is 6, so you get an x to the 6. So as predicted, we get our x to the power of 14. This number times this number is kind of a big number, negative 42,240 times x to the 14. Wow. Do they actually have that question on the exam? Yeah, sometimes they do. I know it sucks. Like, sometimes you get exams that just, the overall mix of questions is just a little bit on the easier side. And other times you get exams where just the overall mix is just kind of on the trickier side. They do try to balance the exams, but, you know, we're only human. Okay, should we do another one? Yes, we should. But you should pause the video and try it yourself. Okay, so same pattern as before. Pause the video right now, okay? Because I'm going to do this question, but sort of a little bit quickly. Pause it, and then I'll give you the answer, okay? So you need to go find term 1, okay? When you go find term 1, what you're going to find out is that you get an x to the 48 term. Then you go find term 2. And what you're going to find out is that you're going to get an x to the 42 term. Believe me, once you have the 2 consecutive terms, the pattern is established. It's going down by 6 every time. Okay, so how far do you have to go? What term do you get to until you get no x's? So in other words, an x to the 0. Well, you could go 48 divided by 6 to figure out how many terms you got to go. Or you could just count it out. Like you could just go, well, the next one would be x to the 36. And then it would be x to the 30. And then x to the 24. ... Keep track. This is term 3, term 4, term 5, term 6. Eventually, you figure out it's term 9. Yeah. So k is 9, and then you can use the term formula to figure it out. Oh, yeah, it says find the term. It's not clear if they just want to know what term it is. I believe that is actually what we're looking for. Find the term. Actually, no, I think that suggests like actually what is the term. So you use the formula, right? So n is 12, so you go 12, c, k minus 1, 8. And we already know you get no x's, so we can sort of skip some of the calculations, but it is going to be this, 12 minus 8 raised to the power of 4, and then it's going to be this, raised to the, this plus this has to be 12, so it's got to be 8. Right, so what happens to the x terms? 4 raised to the power of 4 is 16. And then down here you have x 2 raised to the power of 8 to get 16 again. So the x's cancel. What are you left with? Whatever 12c8 is, and whatever 2 to the 4 is, times 1 over 2 to the 8. Okay? When you work it all out, you're going to get this. Now, again, this is a little bit trickier. I guarantee you that if they gave this to you on the exam, they probably would make this a little bit nicer, but this is just slightly harder, and that's a good place to train. Now, when I run a half marathon, that's 13 miles. I don't stop training at 12 miles. I usually go past 13, right? A little bit harder, but not too much. Okay. This is very long. I don't think we're going to do this one. I can certainly give you an answer, so you can try it out. Maybe I'm just reading it. Determine the value of n. Oh, yeah, this is a brutal question. I was on an exam one year. They've never had it back. Maybe I'll briefly talk about it. So this is saying the fifth term in the expansion of this contains an a to the 4. Determine the value of n. Boy, this is not obvious at all. So you go to your term formula. Okay, now look, it's hard because this is raised to the power of n. Okay, so it's going to be n, c, and we know that if it's the fifth term, k is 5. Okay, so it's always k minus 1, so that would be 4. And then we know it's going to be a to the 4 raised to whatever n minus 4 is. And then it's going to be this. Like this plus this has to equal n. Right? But if you look at the formula, that's how I've been doing it. But if you look at the formula, where is that formula? Gosh darn it, how many slides back do we need to go? This is ridiculous, DeMuro. It's k minus 1, right? So k minus 1 we know is 4. So that's handy. So this is power of 4. Now, determine the value of n. Well, this is just a coefficient. And really doesn't help us find n. Not at all. It's just this will give us a number. Okay, so we can cross that off. I know that's kind of weird, but it's just the number that's out in here. If we're going to solve this, we can solve just this part of the formula here, right? So we know that you're going to get a to the 4 times n minus 4. And then this term you can actually calculate out. Right? We're just looking for what the value of n is. So 3 to the power of 4 does not affect the value of n. Right? You'd have to go negative 3 to the power of 4. It doesn't affect the value of n. So we can actually skip that. Isn't that amazing? You can skip that part and you can keep it as just 1 over a to the 4. That's going to affect the value of n. So now you have this. So if you distribute this in, you're going to get a to the 4n minus 16 divided by a to the 4. What do you do when you have the same base and division? Well, you can write it all as one term as long as you subtract the bottom exponent, right? So there we go. Now you're here, and we know, because it says over here that this contains an a to the 4, we know that this has to equal a to the 4. And now you can solve. You're back in the logs unit. Check it out. Same base. What do you do with the exponents? Wow. Boom. So solve this equation, and you get that n equals 6, right? Add 20 to both sides, divide by 4. Whew. Is that going to be on the exam? No. Okay. So me just being a little paranoid and showing you this question, you probably don't have to worry about it. But hey, as a challenge question, great. Okay. We made it, you guys. I'm so proud of you. We got the very last exercise, 8.4, 8.5. Some supplementary questions I'll put in the video description. Thanks so much. You guys wrapped up grade 12 pre-calc. Congratulations. And see ya next time. Bye-bye.